Welcome to another video for physical science. In this video we're going to discuss sunspots and why they happen. So as we dive into the occurrence of sunspots, let's take a look at the surface, or actually underneath the surface of the sun, and we're going to look at what is responsible for these sunspots. So as we look at the three inner zones, starting from the core, the radiation zone and the convection zone, and then we're going to move over to the photosphere. This is where sunspots are located. This is where they're seen on the surface of the sun, the photosphere. But what you see on the surface is due to something that is occurring just below the convection zone. So in the convection zone, you have a transfer of heat that's radiating from the core, radiation zone, and then the convection zone. And as that energy is transferred from the inside of the sun to the surface of the sun, you have that energy waving out. Now, as that energy is transferred to the surface, some of the gases cool off, and then they will sink. They will dissolve. They will dissolve. They will dissolve down to the core once again. And then, of course, you have hot gases that will rise again. And then you have this dynamic movement, convection. You have these convection currents that are occurring that create this movement. So energy is being released out, and you have your convection currents that are happening all around the sun's surface, and all that energy is being released. Now, something to keep in mind with the sun's surface is that unlike the Earth, so if you were to compare the magnetic field lines of the Earth to the sun, you would see something very, very different from that of Earth. Now, the Earth's magnetic field lines are really nice and organized for us in the north to south poles, but in the sun, you have millions of magnetic field lines, and they're pretty random. And what can happen sometimes is that these magnetic field lines, they can overlap each other and entangle each other, and they will actually begin to interfere with these convection currents. Okay, and as they interfere, they can lessen the amount of energy transfer that they have. And what happens then is that you have an area of the sun where the surface, those gases, become cooler than their surrounding gases. And that's what you end up with, sunspots. Okay, so here again is a look at those magnetic field lines from the sun. Very random, very different, very dynamic from that of the Earth. Okay, and then they create these massive cool gas craters that are bigger than Earth, and we see them as sunspots. Now, something to keep in mind here is that they look dark, right? You'd think it's pitch black, but that's actually not what's happening. If you actually put them next to the full moon, they're up to 10 times brighter than the full moon. Okay, so it looks dark compared to its surroundings because well, the sun is a very brilliant star. That area happens to be not as brilliant, but it is still bright. It just looks dark to us, relatively speaking. Here, it's dark. So again, here's the sunspots, and they're pretty dynamic. Now, the first to notice these sunspots is actually Galileo. When he put a telescope up to the sun, he noticed that these dark areas, and he also noticed that as he was drawing these out, he noticed that the sun actually rotated. Okay, and they can kind of look like storms, like hurricanes. So those are the sunspots. Now, something else that occurs because of the convection currents underneath the surface is something called granules. So here's a CGI, computer graphics image of the surface of the sun, this photosphere. So keep in mind that these are all hot gases. It looks like water waves, but this is just that dynamic motion of the photosphere. And these granules, these wave-like motions, okay, these divots that occur in the sun's surface are as a result of the convection currents underneath the sun's surface. So it's a very dynamic star, a lot of movement, and that does it for our explanation of sunspots. And good luck in your studying.